Let us continue our discussion on proportional variables. So the variable p denotes the expression 2 plus 4 equals 6. The variable q represents Chennai is the capital of Tn. The variable r says Delhi is Union Territory, and so on. So, in a formal argument, we are interested in the statement as well as the truth value associated with each of them. But often, for example, this lecture itself, when I speak sequence of logical statements. So if you associate meaning to each of them, then you can associate a meaning to the logical argument as well. Put it in other words, if you are given an arbitrary argument, we are interested in knowing is the given argument is true or not. So to talk about the truth value of an argument, I should look at the truth value of its individual statements, and using which one can talk about the truth value of the underlying paragraph or the argument. So, which means from this we should move to compound statements. How are these things formed? They are formed using logical operators. And the statement say P or Q. This is inclusive R. Okay. So this says 2 plus 4 equals 6, or Chennai is the capital of Tn. Now this statement P exclusive Q so this statement P exclusive or Q says either 2 plus 4 equals 6 or Chennai is the capital of Tn, Tamil Nadu. So we are not interested in are these two statements related and so on. They represent some propositions and we are relating them using the logical operator, and upon relating them using this or this operator, we would like to know what is the truth value of this. And this is P exclusive or Q. We call it as XR. The symbol is this. For this one, it is P or Q. Okay. We also have something called P and Q. This one is P logical and Q. This says 2 plus 4 equals 6 and Chennai is the capital of T. So now, given these proportional variables, one can make compound statements using logical operator of this type. And 2 plus 4 equals 6 is true, and Chennai is the capital of Tn is true, and now the truth value of this one is true. So what if this one is true and this one is false? What if both are false? And things like that we will see. So once we know the truth value of each of the proposition, what is the truth value of the statement P or Q? What is the truth value of the statement P exclusive or Q? P and Q is something we will see now. So P is a logical statement, Q is a logical statement. So this can take true, this can also take true, this can take true, false, this can take false, true, both are false. Now the truth value of P or Q is the following. It is or, inclusive or, at least one has to be true to say that the logical value of the statement P or Q is true. When both are false, this one is false. P exclusive or Q, this is XR, exactly one of them must be true. If that's the case, the truth value of P XR Q is true. When both are true or when both are false, P exclusive R is false. Fine. P and Q. So it says and. So when both are true, it is true. In all other cases, it is false. So in some sense, these operators are binary operators. I need two proportional variables. We also have a unary operator. Unary means one, which is negation. So you have P, you have negation P. If P takes the value true, negation P takes false. If P takes false, then negation P takes true. Now, the context could be anything. So we are not interested in the exact instantiation of P. Does P refer to the statement 2 plus 3 equals 6? Does Q refer to the statement Tamil Nadu is, one of the premier state in the country, and things like that. We are not interested in specific instances. Instead, given a logical argument involving compound statements of this type, we would like to know what is the truth value of P or Q, P exclusive or, and so on. Now, for each of the compound statement, you find logical value using which one can talk about the logical value of the given argument. These operators are kind of familiar to you in some form, and you may even come across in other courses such as digital logic design, computer organization, and so on. But there are very specific operators such as implication and by implication, which we commonly use in our day-to-day life. We also use heavily in natural language. But the beauty of logic is it just focuses on not just the statement, it focuses on the meaning, semantics. Now we shall see the two operators which are very specific in the field of logic, and almost every expression that you come across in natural language in day-to-day life, you can express using all of this, in particular implication and by implication. So the implication operator So you are given P, you are given Q, the possible values are true, 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 false, false, true, false, false. We write P imply Q. What is this? This refers to P implies Q. So equivalent statements are if P then Q. So P is sufficient for Q. Q is necessary for P. Q follows from P. There are some more which we will see on the fly. So in English, we use statement like this. If P then Q, P is sufficient for Q, Q is necessary for P. You can take special instances for P and Q. For example, I say, if it rains, then I carry an umbrella. Okay. If I scream, then it contains sugar. And one can cook many examples. If I prepare well for JEE Advance, then I can make it to IIT. So things like this. Now if you see, in this case, it rains as P, I carry an umbrella is Q. How do you formally write this? You write like P imply Q. If I scream, ice cream is your proposition, then it contains sugar, this is your proposition Q, one can write using P imply Q, and so on. Now what we want to know is the following. It is a declarative statement, and it takes the truth value true or false, and similarly these are all propositions, these are all declarative statements taking the truth value true or false, thereby it is becoming a proposition. Now you have propositions, you have combined them using this operator. So this operator precisely refers to statement of this type. Okay. Now we want to know, it is raining, say true, I carry an umbrella is true, then what is the truth value of this statement? If it rains, then I carry an umbrella. Now it is raining, true, then I carry an umbrella is false. I want to know the truth value of the statement, and so on and so forth. Okay. So now each of the propositions can take some truth value that could be true or false, that could be true or false. Then we wish to know what is the truth value of the compound statement if P then Q. Okay. So interestingly, when both are true, it is true. When Q is false, P is true, truth value is false. When P is false, irrespective of the value of Q, the statement P imply Q is evaluated to true. We will see some more examples. We will see in detail why this is false, rest all it is true. I repeat, given two propositions, we combine them using this operator, and this operator in English refers to statements of this type. If P then Q, P is sufficient for Q, Q is necessary for P, Q follows from P. Examples: if it rains, then I carry an umbrella. If I scream, then it contains sugar. And if I prepare well for JEE, then I can make it to IIT. So when you come across statements of this type, when you want to translate them and bring abstractions out of it, you express them using the operator implication. Now we wish to know, given this table and two variables P and Q, what is the truth value associated with P imply Q. Once we get to know in a context, if this statement appears, then using the value of P and Q, I can comment what is the truth value of this statement. I can comment what is the truth value of this statement, and so on. Okay. So let's look at this one more carefully and understand this truth table better. Listen, in case of logical OR and exclusive OR, if P was true and Q was true, we were asking what is the truth value of P or Q, P and Q, P exclusive or Q, and so on. In a similar sense, we ask what is the truth value of P imply Q given this snapshot. Okay. Listen. Suppose I make this statement: if it rains, I carry an umbrella. Now I want to know what is the truth value associated with this. How do you write this? Informally, if you write, it is precisely P imply Q. Please note, it is raining, true. I am carrying an umbrella, then the statement is respected. Statement says, if it rains, then I carry an umbrella, then the statement is respected. So the truth value associated with the statement is true. Okay. For example, one more example. You get a circular from academic office saying, if Saturday, then holiday. So you see this circular on a Saturday, and you are the institute has declared holiday, and which means the circular is respected. The statement is true, so Saturday is true, and you are the academics section has declared holiday, which means the circular is respected. So the logical value associated with this statement is true. And look at any ice cream, and it contains sugar. So this statement is respected. Okay. So now let's look at other values of P and Q, and let's revisit the true cases of both again, so that you can appreciate the intricacies involved. Let's look at this. Please listen carefully. It says P is true and Q is false. It is raining is true, but I am carrying an umbrella as false. Statement says if it rains, then I carry an umbrella. Now this was the statement I made, and now I want to know, is the statement I made true? The logical value associated with that is true. Now this statement is violated. It is raining, but I am not carrying an umbrella. The academic circular says Saturday implies holiday, but on some Saturday you are asked to report for classes, which means the circular is not respected, the statement is not respected. Premise is true. This is called premise. Premise is true. This one is called conclusion. Conclusion is false. Which means the statement we made or the circular that was given to us stands invalid or not respected. Which is why when premise is true and conclusion is false, the truth value of the statement P imply Q is false. So you find ice cream, but it doesn't contain sugar. Then this statement is not respected. Which means the truth value of this statement when ice cream is true and not containing sugar, meaning Q is false, then this statement is false. Truth value associated with this statement is false. I repeat again, we are focusing on the truth value associated with each of them when I instantiate P and Q with respect to this truth table or possible values for P and Q. I prepare well for JEE, then I made it to IIT, and both are true. Then the statement the logical value associated with the statement is true. Okay. Let's look at the other two. Please remember, this only says if it rains, I carry. It is not raining. So the premise itself is false. You can look at these statements when premise is true. It is not raining, but I am carrying an umbrella. I may carry an umbrella. Probably outside it is sunny. It is not raining and I am not carrying an umbrella. But I am saying truth value of this statement is still true. The statement only says if it rains, then I carry an umbrella. I can talk about the truth value of this statement when the context is raining. It is not raining and you may carry an umbrella or you may not carry an umbrella. Independent of this statement, you may carry an umbrella or you may not carry an umbrella. However, this statement is still true. This statement, if it rains, then I carry an umbrella, is still true. That is which is why we say the truth value associated with this is true. Look at this. You look at the circular on non-Saturdays. For example, I look at this circular on a Friday. it says false, which means premise is false, it's not a Saturday. Look at the circular on, say, Friday. On a Friday, you may get holiday, probably it is a Good Friday, or you may not get holiday. Whether you look at this circular on Friday or Thursday or Wednesday, this circular is still true. This circular says if Saturday then holiday. So circular is applicable only on Saturdays. So whenever premise is true and conclusion is true, you get to see truth value. When premise is true and the conclusion is not respected, then this statement is not respected. When premise itself is false, which means I cannot talk about truth value of this statement, in the sense that I cannot bring in the relation between these two. I can talk about the truth value in the sense that since premise is false, I should not even look at this circular. This circular is always true when premise is false. This statement is always true when the premise is false. The statement is applicable. I can take the statement for discussion, deliberation when the context is rainy. Premise is you look at an item, it is not even ice cream, it is something else. Maybe a jaggery or Mysore pak, it may still contain sugar. Or you may look at some savory, it may not contain sugar. But the statement that it is ice cream implies sugar is always true. And I prepare well for JEE Advanced is false. Probably I am preparing for NEET or I am preparing for some other competitive exam, and this statement is still true. Or I am preparing for GATE and I made it to IIT, or I am preparing for NEET and I did not get into IIT, and it could be anything. But when premise is false, one cannot instantiate any of this statement. Okay, so let me give you a quick review on what we are discussing now. Given two propositional variables or propositions P and Q and possible values for P and Q, and you combine P and Q using the operator this denotes the expressions of this type in natural language. If P then Q, P is sufficient for Q, Q is necessary for P, Q follows from P, and so on. Now we are interested in knowing what is the truth value associated with this statement. Suppose the statement is like this: if it rains then I carry an umbrella. It is raining outside, true, and I am carrying an umbrella, then the statement is respected. Truth value associated with this is true. When premise is true, it is raining, and I am not carrying an umbrella, then this statement is not respected, which means true false implies false. This statement will not be taken into consideration when the premise is false. For example, it's not raining outside, I may still carry an umbrella or I may not carry an umbrella. But the statement it rains, if it rains then I carry an umbrella is still true. Okay, which is why when premise is false, the logical value associated with P imply Q is always true, independent of the conclusion. Okay, we will look at some more examples to understand this better. Okay, let me highlight a couple of more on this item after discussing some more examples on if P then Q. They're all equivalent. In a natural language, we use all this interchangeably. Fine.